Thank you. I'm Jean-Laurent Philippe. I'm the Intel European, Middle East, Africa IoT Technical Manager, and my team is spread all over Europe. And I'm going to try and tell you a little bit about where Intel is going with Internet of Things. I'm trying to not spend too much time on things that we've already seen this morning because everybody agrees on a lot of things. And the idea is that IoT is here to stay, and we heard Eric say that this morning. He said IoT is here, and I think it's here to stay. We're just on the rise, and we need to make sure that we provide all of the building blocks from Intel that will help develop even further the Internet of Things. We are seeing already a few things that are happening with the development of super cities or megapoles, with the rise of the Gen Y and the future generations of people who are born connected, unlike some of us who are getting a little bit older. And what we know is that they want a better life, as measured by, in many cases, health and education. So that's one thing that is very important. However, they are not ready to get that at any price. And the security of the information and the privacy will be some very important aspects for them. This morning we heard some very interesting presentations that talk about the edge and a little bit about the gateway. And all this is great for research and for development, but we need to make sure that there is value in it. Where is the value for the Internet of Things and for the intelligent solutions? We know today that all of the things are connected. They generate a lot of data, but in many cases, either we don't know how to harvest the information which is in the data, or even worse, I see some customers who tell me, I know that I have a lot of data, but what can I do with it? So people don't really know yet what they want to do with it. So Intel's goal on the longer run is to deliver integrated, scalable hardware and software solutions. So Intel is mostly known for the CPUs that you probably have in most of your laptops, but we are also a software company. If all of the software developers from Intel would be a spin-off, they would be the 5th biggest, or 4th now, biggest software company in the world. We have several thousand software developers. So anyway, going back to the goal, it's really to provide those solutions, hardware and software, scalable, integrated, and that are designed to meet diverse market needs from devices to the cloud. This morning we talked about the devices. We'll talk a little bit more about the cloud. But there are a lot of challenges in terms of getting to the data, securing the data, and keeping the data private. This one I'll go very fast, because that's the third presentation where we agree on the 50 billion, which is very rare. Usually there's a lot of variation on this. Anyway, lots of devices generating a lot of data. This morning we talked about the sensors and the actuators, and we have seen some very interesting presentations with typically the Riot that will be that would be potentially the OS getting all of these sensors and edge devices getting all together and speaking the same language and making it easier for developers to use. They are connected to the gateways that are receiving 3G or 4G or Zigbee or Z-Wave or anything so that they can speak the same language. This information that is aggregated on the gateway goes to the network, and then in the cloud we will get all of the data that is available and through APIs exposed to people who will make use of it through applications. This data here will also be used for data analytics, or as people call it now, the big data aspects. What is interesting is that the cost of sensors has significantly decreased in the past 10 years. The cost of bandwidth has even more decreased, and the cost of processing or of computing has kept on decreasing also very fast, and will likely keep on decreasing thanks to Moore's law. Where are we on IoT? My view of it is that we are on the hype curve at the highest, which is everybody is so excited about it and feels that they need to be in it, that we are all getting there. We are going to go through the down of what we call disillusion, which is, oh my God, it's not ready yet for prime time. And when I say not ready yet for prime time, I mean that it's not so easy to get the end-to-end solution together. Not all of the gateways are capable of talking all of the languages of the sensors. Not all of the sensors are secured. Not all of the data is secured. The APIs in the cloud are not all managed or manageable. And the data which is in the cloud is not always usable, because we don't know always what to do with it. So we are getting to a point where we need to make it a little bit more easy for the real users, those who have the money to pay for all of this, to get it done. So that's in transportation, in health, in cities, in building, smart cities, smart buildings, smart home, retail, etc. There are plenty of areas where there is something to take. This is probably the slide that I'm going to spend the most time on. The tenets or the canons that are very important for the Internet of Things, for the end-to-end solution, are based on these different layers of information. We want at the hardware and software level that the security be guaranteed. I know that it's not easy, but we are starting, and at the hardware level, already in the processors that Intel manufactures, there are some low-level security aspects. And then when the processor boots, it will first get to the BIOS. We are securing the boot sequence so that the BIOS is guaranteed to be not tampered with or not modified. How do we do that? We make a hash of the BIOS. We compare it to what is actually running, and if the two hashes are the same, there's a very, very high likelihood that the BIOS is the one that we put on the machine initially, wherever it is, on the edge, on the sensor, on the gateway, on the cloud, on the server, everywhere. Once the the BIOS has run, the firmware has been guaranteed, then we know that the machine can be more or less secure in terms of low level. And what we want to make sure is that the next thing that we run on it, typically the agents that we run on the edge device, typically, are the ones and only the ones that we expect. We have created a solution based on whitelisting in which we are sure that if an agent is running on the edge device, it has been checked against the list of agents that this edge device is supposed to be running. So we load all of the agents that are needed, and then if I come up with an agent, a malware that would be trying to run on this edge device, then it's not listed on the list of guaranteed and secured and approved agents, therefore it doesn't run. So unlike what you have on your laptops, which is the antivirus that is trying to check that something is weird, here we know what is good and we only allow what is good to run on the device. And then we have exactly the same things in terms of the cloud on the servers, but already on the edge we have that. So security is a very, very important thing. We also have encryption from the edge to the cloud. We want it to be very easy to put together. So the first part of getting the setup from the box to the cloud needs to be feasible in minutes. And then, once the setup has been done, we want that all of the edge devices, as well as the gateways, are discovered by the cloud in seconds, not until hours or anything like that are gone, but we want it to be kind of immediate. So all this is very important and can be done with a lot of the hardware and software solutions that Intel is enabling. Then these devices and gateways are going to provide some data. And all of this data will be ingested and then processed on the edge in some cases, because we want enough intelligence on the edge so that we don't need to send all of the data to the cloud and then return the action that needs to be taken from this data. But if we can get as much compute efficiency done on the edge, that's already a good thing, because we don't need to travel all of the way either to the gateway or even to the cloud later. However, remember that we still want some information to get to the cloud so that it can be done in terms of analytics or big data later if it is needed. So we have to find the right level of balance on this. Then, when we have all of this data, we want to get to the next point, which is the data analytics, with the broad analytics infrastructure that will be available in real time if we can, and that gives enough information about what we are searching, and so that it is secured also. And on top of it, all of the services for monetizing the hardware and the software and the data management that is available. And that's done to make sure that the customers get the value out of the data and the installation that they have. We have seen this morning that there are plenty of paths that are going in all directions, and I think it was Eric who was saying that from 2012 to 2014, the number of different what do you call that? Standardization bodies, I think, in terms of IoT, went from 2 to 7. And the goal of Intel is not necessarily to try and be the one defining and developing the new next standardization solution. It's more to enable the ecosystem so that all of the solutions work together. In the IIC, Intel is trying to have a reference architecture and some frameworks and test beds that will generate more interoperability so that everything works together. And on the second one, the OIC, Intel is trying to help with the industry standards that already exist, not trying to get more, and to find some solutions that are open source. Because we know that in this world, which is blooming at the moment, there is so much new areas that are available and so many people developing solutions that they need to be as much as possible based on something which is open source. So Intel is making as much of the software as possible open source. And by the way, Intel is the biggest contributor to the open source in the world at the moment. The goal is really to enable the ecosystem and have as much interoperability between devices, standards, gateways, cloud as possible. So we know that IoT is growing very fast, but there are some challenges to it, to this growth. I talked a lot about the security, the privacy, and also the compliance, but there are many others, and just because for each solution, for each vertical segment, there is a solution. Intel is trying to find a way of getting to something that will be horizontalized, so that it can be reused in all of the segments, and only something specific to each vertical will have to be developed. The device to cloud security will be part of all of the horizontal elements, manageability, data management, API management. As I said, the value of the data is made high if there are some APIs that can expose it to additional applications. Example, London has installed a lot of sensors to check level of pollution, temperature, humidity, and stuff like that. Instead of keeping it for themselves, they have just exposed it to the world through APIs. So if you know the format that the API is allowing you to use, then you can reuse it for your own application. There is an application that I heard of, I don't know if it has been developed, and the idea was, I want to jog in London, and I know that I have to anyway take the subway to go to a park. I can check in which area of London, based on the sensors, there will be the lowest level of pollution. Very likely in London it will be towards the west, because the winds are always blowing in from the west, or most of the time, except that I might be unlucky and they are blowing from the east this day. If I can have this application that checks what the weather will be like, where the winds will be blowing from, and this application will tell me, in order to get the best spot to jog today, you have to go to the northwest of London, and here are the parks that are there, then that's easy. But it means connecting some data that is available from sensors to some information that is coming from other parts of the internet. And that's just an idea. But the numbers of possibilities that there are to get value out of the Internet of Things data is huge, huge, huge. The limit is just the sky, or your brain and your imagination. Intel is contributing to it and will never be the one providing the solution that solves world hunger. Of course not. We are providing some hardware building blocks and some software building blocks. And in December, we announced the IoT platform, which is a group of elements that provide reusable, actionable, and secure building blocks, software, a little bit of hardware, based on Quark, depending on what you need for a gateway to be at a low level of performance, or based on Atom, if you need a little bit more computing power. And that is something that is now available for the users to develop their own application. As I said, it's all about reusability, security, and interoperability based on standard hardware platforms that are optimized for the workload that you need. The capabilities are to make sure that things easily connect to the gateway, that the gateway is secure and managed or manageable, and that it can do some analysis of data already if the edge devices are too, let's say, stupid or dumb or don't have enough processing power to do this analysis. We talked a lot this morning about some sensors that are with, let's say, small microcontrollers, but on the edge, you will see more and more some pretty high performance devices. The typical example of that are the video cameras that you can see in some cities. I was in Moscow and I was in press interviews last Tuesday, and we talked a lot about this. In Moscow, they already have 130,000 cameras. And I was invited to the city hall, and they have some edge analytics solutions that can, just by software looking at the images, they can see if someone is trying to get in fight with someone else, if it's just some people gathering and talking, or if there is something bad happening. They can already monitor a lot of things because they have written in software some recognition, some pattern recognition of what's happening. So, well, Moscow is a city like any other big city, and trust me, the context of, or the concept of smart cities is evolving very, very, very fast. Some city halls look at it from the point of view, I want to decrease pollution. Some of them look at it from the point of view, I want to decrease crime, but there are plenty of other ways of looking at it. So the idea of having some stupid or basic computing devices at the edge is going to evolve from those temperature or humidity sensors to some very, very clever and high performance edge devices like these video cameras. Because if you want to analyze the stream of data that is coming directly into the camera on the edge, you need a lot more than just a stupid microcontroller. You need a real processor and some good software, by the way, also. So the analysis is very important on the edge or close to the edge on the gateway. Exposing the data to the user is what I called the API that will make it readable for some others. And then getting into prediction of what will likely or could likely happen, and then optimization of the environment. Those are the next steps that will be made feasible with that. I'm not going to talk a lot about this example, but I want to just remind you that this morning we talked mostly about all of the edge and a little bit about the gateway, but there are plenty of other areas where Intel is playing an important role and that we are very much focusing on, which is the cloud with the data center and all of the storage and all of the analytics. And in green, in green compared to blue, you have all of the areas where security is important. We heard a little bit about it this morning. Security is something that will have to be developed significantly. We are taking it at the beginning and at the basis of all of our development. Security is our first level of involvement, and then on top of it, we provide the other things. Intel is also providing additional things on top of the hardware. There's a software, a piece of software, which is called trend analysis software or trend analytics software, which is made available by Intel and that is helping with the big data analysis. And we already have some customers. Daikin is an interesting one. Daikin is those big air conditioning machines that you have on top of huge buildings. And the issue that they had until now was they had absolutely no clue in which shape and health their air conditioning machines were. And they had to send periodically, that can be every 3 months, every 6 months, every year, someone to check the health of the machine. And with some small additional sensors that they have put close to the engine, close to the machine itself, they can now remote monitor what's happening on the machine, and they have created some pattern recognition algorithms that check the noise that the engine makes. And they know that if the engine starts making a slightly different noise, it's likely that within a certain number of weeks, something will break. If an AC breaks, they have to send immediately someone to repair it. Sometimes they have to replace it. On top of a big building, it's extremely costly. What they can do now is get to the preventive maintenance at the right time, and they are saving a huge amount of money for themselves, but also for all of the building management companies that have to pay some fees, typically when the air conditioning breaks and some machines or some people are not happy with that because for several days, potentially, they won't have the service that they were expecting. So it's an interesting solution that these guys have put together. Another piece of software that Intel is providing is the edge management system from Wind River. Wind River, let me remind you, is an Intel company. So in terms of security, IDP, EMS, Wind River is providing the low-level OS and edge management system agent that will be helpful for any embedded solution. McAfee also is an Intel company, and it has been renamed to Intel Security. And we have announced last week another solution for increasing the security of the infrastructure for IoT. Intel Security, which is the name for McAfee, of course, keeps on working on malware, increases resiliency, check the identity of the device or of the person who is connecting to a device or a machine, and is protecting the data. But we have created an end-to-end security solution that guarantees the physical security of the device, the identity of the device. That's based on what I explained earlier today, that we check the hardware itself, that it has not been tampered with, the firmware, the BIOS, the OS, the agent, that we also secure the communication machine to machine with AAA, authentication, authorization, and accounting, and we guarantee the confidentiality and the integrity of the data. And how do we do that? By creating some new ways of getting some virtualization even in embedded, by guaranteeing that there are some containers of solutions that avoid any, let's say, communication of information between processes or between agents or between solutions. And all this has just been announced, I think it was last week, in an event in the US. I'm not going to spend a lot of time on this, but just to give you some examples of where Intel is playing, the one that I'd like to spend a little bit of time on is, here it shows a smart industry with Mitsubishi Electric. Actually, when you look at it from a low-level point of view, it's the Intel example itself. Intel has several fabs. We call them fabs. That's all of the big manufacturing plants where we either manufacture our silicon, the silicon for our processors on the wafers, or where we take the silicon and we assemble it onto a small piece of board, so that then it becomes the processor that you put, or that OEMs like HP or Dell or Apple put in their machines. So we have several types of assembly and manufacturing plants. We have had IoT in those plants for very, very, very long time. We didn't call it Internet of Things, but we had millions of sensors that are checking temperature, humidity, and the quality of the air, that are checking the health of each machine that we are using. And those sensors are extremely important because the way Intel manufactures processors is always the same. We develop a new process technology, and when we have it fully under control, we do a copy exact into another fab. The issue is that we have some fabs in Oregon, which is quite humid and not too hot. We have some fabs in Arizona, which is extremely dry and very hot. We have some fabs in Israel, in Ireland, now in China. They're all in different environments. And in each of them, we must make sure that we guarantee the same conditions and that we need to control any deviation, otherwise we won't be able to replicate. And each fab now costs approximately $5 billion. If we mess up with one, it's a lot of investment that we must write off, and we can't afford that. So in order to do that, we have had in all of our assembly and test plans on all of the lines, many sensors that check everything. And in the past few years, just on this assembly line, not on our manufacturing plant, we have been able to get some benefits of several $1 million, which is always a good thing to get. So we use, or as the Americans say, we eat our own dog food, because we use our own solutions internally first, and then we say, hey, we have some ideas of what works in the industrial vertical, and then we can share it with other companies who are interested in learning what we have done in terms of managing a solution that is end-to-end and that brings a value. And the measurable value for a company is either more money that we make or less money that we spend. And in this case, it's always a good thing. I talked with some of you earlier today about the solution that Rudin has been putting together by managing even better all of the electricity, air quality, and other temperatures in some very huge buildings. And they are capable of saving also millions of dollars in terms of how much it costs to heat or cool or put some lights into a building. We do that in Europe in many ways. One way is we have just opened in 2014 4 IoT ignition labs. One in Swindon, which is 100 kilometers west of London, one in Stockholm, one in Munich, and one in Istanbul. And those labs are where we invite any company who wants to do something with IoT and who has a great idea, but they don't know exactly how to get it to work. End-to-end, from device to the analytics. They come to us, we have some engineers, and we work together if there is something that can be good for them, because in many cases, they don't have yet a good business model, and the idea that they come needs to be refined before they get to which hardware, which software solution, which edge analytics, which gateway, which software on the gateway, which APIs, which cloud analytics they need to put together. When they have a good model, and they say, well, we don't want to invest millions of dollars into something that we don't know will work or not. So we do a small proof of concept together in one of our labs with a few of their engineers, with a few of our engineers, and then they see if something good comes out of it. A couple of examples is Siemens Smart Parking. Siemens has come up with the idea that with all of the light poles that there are in the cities and in the parking lots, it would be a good idea to help people find the best parking spot for their car when they are searching for one. So with all of the, on all of the poles, their idea is either to add a sensor that checks whether in an area of a few tens of meters there are some parking places, and they can put that up into the cloud, accessible for an API to check. Or they have another idea, which is, well, maybe instead of adding a sensor to each pole, we can use or develop a specific light bulb that will include and incorporate already a sensor that will check, and when they have to replace the light bulb next time, then they will put one of those light bulbs that will have the sensor capability. When they have all of this information about which parking place is available or not, then there are some other companies like the City Hall that can make available through an API to you on internet, on your smartphone, or even potentially on your navigation system in your car, the information, where is the closest parking place for me in this city or close to this area. So they have already done in Munich POC, a proof of concept of this. They are planning on doing it in a couple of streets in Berlin in the future. Dubai has already said, hey, I'm interested, I want something like that. So that's one of the examples that we are working on. It took them, let's say, a month or so to put their idea together. We had the POC done in a few weeks, and now it can be grown up in a bigger scale, and they could productize it. And we have plenty of ideas like that are at the moment confidential, because of course several companies don't want to share ahead of time what they are going to come up with. But again, the sky is the limit. So what is Intel doing in IoT and for IoT? I talked about it, and as a summary I will say Intel is providing the hardware performance that is available through the Moore's law, which is the number of transistors double every 2 years or something like that. Or if you want to stay with the same number of transistors, then the power consumption decreases by the same factor or the square root of it, depending on how you want to look at it. And we have seen, well, and you all work with some Raspberry Pi or other solutions, but maybe you have heard of this new small device that Intel has announced a few weeks ago, which is called Curie, just like Pierre and Marie Curie, which is the size approximately of a button, and that has enough compute power and communication capabilities so that you can get to something extremely small when you really want to get to very, very condensed and dense solutions. Intel provides some analytics software, as I said, a little bit smaller than this. Security, as I said, is an extremely and basic need that Intel is taking into account from the hardware to the software, and the interoperability through the IIC and the OIC. And as a conclusion, I will say that the new offering and relationships will make it easier for the solution providers, those who are building those solutions, to move IoT from just pilots at the moment or proof of concept to mainstream deployments with easiness, with repeatability, and for limitless solutions. And the goal is really to make the data bring some value as measured by either more money earned or less money spent for both consumers, so that's the car or home data, home automation and things like that, or the businesses. And we are seeing IoT being more and more valuable to those businesses. First example, as I said, was Intel using IoT to save some money. And with this, I'm done. Thank you very much for your attention. And Didier has already put the slides up on the wiki, right?
Yes.
So they are public, you can take them. Any questions?
Just a relax. If you want to practice with IoT technology, there are a tutorial on Intel Edison tomorrow afternoon, I think, with Olivier. No question?
Thank you.
Thank you.